So what we're going to do in this second video of transposition, we are going to transpose formula containing roots and powers. So in this example, J equals I squared RT, and we're going to transpose that for I. So we're going to divide both sides of this formula by RT. So write the formula out, divide RT by itself, and remember what we do on one side, we do on the other. So they will cancel themselves out, and that will leave I squared is J over RT. So the second thing we need to do now is we need to get rid of the squared. So one way to look at this is the opposite of, obviously squared is the square root. So what we do then is we take the square root on both sides. So that effectively we do that, and that will get rid of the squared and the power. So that leaves, flip that formula around, so therefore I is J over RT square rooted. And it's important to remember that all of that quotient there is actually square rooted. It's not just the top, so it's all of the side is square rooted, just for clarity. In this second example, T is 2 pi times the square root of LG. This time we're going to transpose this formula for L. So we want to get rid of 2 pi, so divide both sides by 2 pi, and that will cancel that out. So the next thing we need to do is we need to square both sides, because if you look at the right hand side, LG, the product of LG is all square rooted, so the opposite of that is squared. So if we put brackets in there, that means that obviously the product of LG, the square rooted, if we square that, that puts it back, so that's the opposite if you like. So what we do on that side, we do on that side. So we square both sides, and that leaves T over 2 pi squared equals LG. So obviously we can also write this now here. So it's saying that the T over 2 pi is squared. That can actually be written, so T squared, so 2 squared is 4 pi. So what this means is that everything within the brackets is squared. So T, so we could call that 1T, but T on its own, it becomes T squared. 2 squared is 4, and pi squared is pi squared, and that equals LG. Can you see what we need to do next? Basically, we need to get rid of G. Okay, so let's do that. So we divide both sides by G. So on the right hand side, that what G divided by itself gets rid of it, and what we do on the right hand side, we do on the left hand side. So the G goes underneath there, and there we go. They cancel themselves out. So T squared over 4. Oops, just play it up. 4 pi squared G. So here's a transposition which a lot of electrical students will be faced with. Basically it's Pythagoras, and we're working out the opposite side of a right angle triangle. So we're going to transpose this for P. So if this was an electrical power triangle, you would have S there, Q on the opposite side, and p on the adjacent side. So obviously we know that that's obviously Pythagoras is p squared. Yep. So what we're going to work out this time is we want to work out obviously the value of p. Okay. So looking at this formula here, where do we start? Well, basically you can see there that we have obviously s squared minus p squared square rooted. So again, what we can do on there is if we put all of that in brackets, we'll square it, then what we do on that side, we do on the left hand side. So now, by squaring the right hand side, we lose the square root, and see the q becomes squared. So now we've simplified that. The next thing we need to do is we need to effectively get p as the target that we're working out. So to remove p squared from the right hand side, we simply add p squared to both sides. So minus p squared plus p squared, well, they will cancel themselves out, and that will leave. Then we need to remove q squared because we want to make p obviously the what we're working out, the subject. We want to make p the subject, that's the word I'm looking for. So subtract q squared from both sides. So they will go, and that will leave p squared equals s squared minus q squared. The next thing we need to do is we need to square root basically that side. So p squared to get rid of the squared in the p, but what we do on one side we do on the total on the other side, on the right hand side should I say. So that will leave p, because the squared root cancels out the square, leaves. There we go. Okay. And that concludes this short video.